Confounding is a comparative experiment in which some units receive one treatment and similar units receive another. Most well-designed experiments compare two or more treatments. Now, comparison isn't enough. We want these two groups to be as alike as possible with the exception of the treatment, and we do that assignment by doing random assignment. Random assignment tries to use random chance to ensure that the two groups are as similar as possible. So let's talk about how we do that random assignment. Um, Definition: in an experiment, random assignment means that the experimental units are assigned to the treatments at random, that is, using some sort of chance process. So let's think of this example. Each year, the high school has enough, this year, the high school has enough budget to compare an online SAT course to the traditional classroom instruction. 50 students have agreed to participate in an experiment comparing the two instructional methods. How would you randomly assign 25 students to each of the two methods? Well, if we're told that we're going to use identical slips of paper, we could say that the names of the students are put onto 50 identical slips of paper. The slips, a period there, are put into a hat and mixed well. 25 slips are removed without looking. Those names are assigned to we'll put them in the online group. What about the others? All others are assigned to the traditional classroom, the traditional course. Okay? Important that we didn't let people choose themselves because that could introduce a confounding as well. But that's one way that we might assign the people to the two groups. But that's not the only way we could do random assignment. We could use a table of random digits. In this case, assign each student a number from, not form, from, now there's 50 of them, so we'll assign them the numbers from 0, 1 to 50. And then from the random number table, get 2 digits at a time. And we're going to ignore repeats and numbers not in the 0, 1 to 50 range. The first 25 students with matching numbers are assigned to the online course. All others, what are we going to do with them? Take traditional course. There we go. What about if we use technologies? Well, let's say we focus on using Desmos. So if we use Desmos, one of the commands that we can do is called the random command. We talked about that when we did sampling. And we could say randomly select 0 dot dot, sorry, parenthesis, and then square bracket, 0 dot 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 1. And then every time we use that command, it produces a number that's either 0 or 1. So this produces randomly zeros or ones. Starting at the top of the list if the random number produced is a 0, assign that person, that student, to the online group. If it's a 1, assign that student to the traditional course. Okay, now when do you stop? Stop when one of the two groups has 25 students. All other students do what? Go to the other group. And that way we get two groups of students. Okay. Now, by the way, if you think of this, 0, 1 thing, we could have done the same thing with the random number table. Okay. With the random number table, you might just do odd even and start at the top of the list and kind of have the same result. All right. So this is the kind of level of detail that we want to put whenever we're trying to describe how is it we're going to do the random assignment. So what does a random assignment, a randomized comparative assignment look like? Well, we're going to allow you to use this kind of graphic when you say I'm designing an experiment. You don't have to write it off in a paragraph form. You can say, hey, I've got my experimental units. I do random assignment to place into groups. Within each group, we get a treatment. And then when we're done, we compare the results. Okay. The control group, is often getting a inactive treatment or getting a traditional treatment, where the other group is getting typically a new treatment. Think about the new treatment as being the online course and the control to be called the traditional training. Um, let's do an example. It says, a health organization wants to know if a low carb or a low fat diet is more effective for long-term weight loss. The organization decided to conduct an experiment to compare the two diet plans with a control group that has only provided a brochure about healthy eating. 90 volunteers agreed to participate in the study for 1 year. Um, Problem: outline a completely randomized experiment designed for this experiment. Write a few sentences in how you would implement your design. So we have subjects. And by the way, it's traditional that we say how many are in each group. So we start off with 90 subjects. We're going to break the subjects into 3 groups. Okay. And we'll say we're going to do this using random assignment. Okay. We're going to get group 1, and that has 30 people. We're going to have group 2, and that's going to have 30 people. And then we're going to have group 3, and that's going to have 30 people. Now, what's going to happen to group 1? Well, they are assigned, they're going to get the low carb diet. It's going to get the low fat diet. And this group is going to get a brochure. And our 3 treatments. And then what we're going to do at the end, we're going to compare the results. Now, how are we going to do that assignment? Well, I think the easiest way to do assignment is I'm going to put the 90 names on identical slips of paper. Put slips in hat. Mix well. Let's draw 30 names without looking. And those go into group 1. Draw 30 more without looking. And those go into group 2. All remaining go into group 3. There we go. Good, effective random assignment. All right. When we do these experimental designs, College Board really wants to make sure that you focus on the big 3 principles of experimental design. Item number 1 is control. The control for looking variables. A comparative experiment ensures that only systematic differences between groups are the treatments administered. So the 2 groups should be as alike as they can be. And we use random chance to do that. And they get 2 different treatments, and that should be the only true difference between the 2 big groups. We use random assignment to help eliminate from possible bias that if we didn't use assignment randomly, getting roughly equivalent groups. And the third thing is replication. Let me summarize this. We need many experimental units. Okay, the more units that we have, the more likely it is that we're going to be able to see a difference if there is actually a difference between the groups. Let's take a look at a well-designed experiment. Does regularly taking aspirin help protect people against heart attacks? The Physicians' Health Study was a medical experiment that helped answer this question. In fact, the Physicians' Health Study looked at the effect of two drugs, aspirin and beta-carotene. The researchers wondered whether beta-carotene would help to prevent some forms of cancer. The subjects in the experiments were 21,996 male physicians. There were two experimental variables, each having two levels. Combinations of these levels of factors are shown in the figure below. A fourth of the subjects were assigned at random to each of the treatments. So one group took both aspirin and beta-carotene, where one group only took aspirin, but then took a placebo instead of the beta-carotene. Okay, on odd numbers days, subjects either took a tablet containing aspirin or a W pill that looked like and tasted like aspirin, but had no active ingredient, a placebo. On even number days, they took either a capsule that contained beta-carotene or a placebo. Several response variables were looked at, including heart attacks, several kinds of cancers, and other medical outcomes. After several years, 239 of the placebo group, but only 139 of the aspirin group suffered heart attacks. This difference was large enough to give evidence that taking aspirin does reduce heart attacks. It did not appear, however, that the beta-carotene had any effect in preventing cancer. Problem: explain how each of the three principles of experimental design was used in this group or in this study. Well, first of all, we'll talk about control, and that some subjects took aspirin, but others didn't. So we're able to compare and contrast those two groups. Some subjects took beta-carotene, but others didn't. There's our control. Okay, random. Which treatment group um, the subject belonged to was randomly assigned. Assigned, making each group roughly equivalent. And then the last one, replication. 21,996 subjects participated, making a difference easier to see if a difference existed. Okay, so there's our three major ideas of experimental design. And that finishes off this first lecture of section 4.2.